All right, welcome to another fascinating, fabulous video. I'm sure you'll can't wait. We just finished up our first unit with one-dimensional motion. Things were going east to west, north to south, up and down, left and right. And our second unit is about two-dimensional or 2D motion, where an object's really is still moving in a straight line, but that straight line is influenced by kind of getting pushed into two different ways. We'll be doing a lot of math this unit. I know some of y'all probably don't like that, but we are, and I will just continue to encourage you to practice as much as possible to make it easier for you. Anything that's hard gets easier with practice. So one of the first things I want to go through is rearranging some basic formulas. We should have done this probably a little bit in the first unit, but we worked through it a little bit. So if you look at the picture on the screen right here, I've got something that's off of our reference sheet. And so it says V average equals D over T. We've been using this for a month. And oftentimes we solve for this V that's right here, and that's usually pretty easy to do. If we know distance and time, we just divide them and we get an answer. However, sometimes we're asked to solve for D or we're asked to solve for T, and that can be a little bit harder for a lot of people to do. Now, in theory, in math, you should know how to get D by itself in this formula, which would be to multiply both sides by T, because D is being divided by T. The way we cancel out a divided by T is to do the opposite of division, and we would multiply by T, and we would end up getting V times T equals D. And again, I'm going to run through these slides pretty quickly. So if I go too fast for you, please pause, rewind it, watch the slide again. So T would end up getting moved over to the left side. So D would end up being V times T. Again, a lot of us don't have a problem with being able to do that. But then again, some of us have a little bit more trouble moving things around and solving for variables. So I want to try to make sure we understand kind of an easy way to do this given certain circumstances. So there's a lot to read up there, but basically what I'm saying is if we have a formula where one thing equals two things, and in this case, the two things are being divided, we can use a triangle over here to be able to put the variables in so that we can solve for any of them. And the idea is if I'm trying to solve for D, if you look at the triangle, if I try to solve for D, then D would be V times T because they're side by side. And when we multiply things, we multiply them side by side. If I were solving for V, then V would equal D over T. And it's a division problem because D is above the T. And so in the triangle, if the letter D on the top is going to be D divided by V or D divided by T, and it would equal the other one on there. Now, the hard thing for a lot of people is getting the letters into the right place. So I'm going to try to explain best how to do that. So our basic rule is that the two variable side of the equation needs to go into the triangle first. In other words, the D and the T need to go into the triangle first. And you want to put them into the triangle, because again, this would start off as a blank triangle. You want to put them into the triangle the same way they look in the formula. So in the formula, D is on top of T. So in the triangle, D needs to be on top of T. Now, T, it doesn't matter where on the bottom that it goes. It could be on either side. The math doesn't really change anything. And then once you put D and T in the right place, you're left with one box and one variable, and we would stick the V in the remaining box. Okay, so another way that it might end up looking is this is a different version of the same formula. Notice again, we've still got two variables over here. You can ignore these little bitty X's on here, but so it's basically saying D equals V times T. So in this case, if this was our formula and you were trying to use a triangle, the V and the T are side by side. So they need to go side by side in the triangle first. So don't try to put the D in first. We'd never want to put the thing by itself in first. We always want to put these two in first and arrange them just like they look in the formula. So if V and T are side by side, V and T need to be side by side in the formula, and then D would go on top. Okay, so I would like for you to take a moment and just kind of pause the video. I've asked you to try to work through several formulas that are on our reference sheets for the rest of the year and to practice using the triangle to solve for each one of those. So I've given you a formula, I've given you a triangle. I'd like for you to put the variables in the triangle and then show what each letter would equal once you are able to use the triangle. So let's pause for a moment and do that. All right, hopefully you were okay with all that. And now we're going to move on to kind of what's in our new unit. A lot of what's going on with our unit is involving triangles because we're going to be looking at motion that's not east and west or north and south. It's going to be somewhere in between. And so what we're calling these are component parts. Like in other words, how like the parts of a vector. We'll get into this a little bit later, but ideally, kind of what we're saying is that if I've got a boat that's trying to row across the river, the boat is moving in the y direction or north, the way that you're looking at this. The river is pushing it to the right or into the x direction. And so there's actually two sets of motion going on right here. And what's going to happen to the boat is the boat's going to take kind of a diagonal path across the river. So by hopefully the middle end of next week, we're able to solve problems like this pretty easily to say, if I know how fast the boat is going and I know how fast the river is going, then I can tell you how fast the boat is going and the actual angle that it's going to be making. In order for us to do that, we need to get pretty good with our triangles. So again, we're not just looking at north, south, east, west. We're doing it into angles right now. And so the key to doing this is we're going to turn all these things into a right triangle and use things that you would have learned in geometry to be in trigonometry to be able to answer the questions about the motion that we're going to have going on there. Again, probably never use this in life, but so be it. We're in physics. Okay. So just as a reminder, when we say a vector, that's a magnitude with a direction like, 10 meters north, 10 meters per second north, 10 meters per second squared north. As long as we have a direction to it, the vector is a magnitude. We oftentimes represent the vectors with arrows, and the arrows can tell us a direction. We've been kind of doing that before, but they also are going to indicate a magnitude or an amount. So the idea is the longer the arrow is, the bigger the vector amount is. So if we're doing a displacement, then the longer the arrow is going to be a greater and greater displacement. Okay. We'll get to this more later. Today, we're mainly just working about triangles. So a couple things we need to do is to be able to sketch out a triangle and make sure we know the vocabulary and all the parts. So I've given you some place on your notes to be able to do this. And we're going to be looking at the words adjacent, opposite, and hypotenuse to label the triangle. And then we've got this symbol right here that's going to show us the angle that we're going to be typically working with. Okay, again, at any time, y'all need to stop and rewind this if you need to. The hypotenuse is always the longest side, and it's always going to be across from the right angle. The length of the side has to do with the angle that's making it, and a right triangle can't have an angle bigger than 90 degrees. The right angle is always going to be the biggest angle. So the angle across, the side across from it's always going to be the biggest side. Think about that with the angles. If the angle shrinks, then the side across from it's going to be getting smaller and smaller as well. Now, the other two depend on the angle that we're using. This can be confusing for a lot of people because adjacent and opposite, if I were talking about a different angle, then adjacent and opposite would end up switching places. So we have to define or know an angle that we're talking about before we know which one's adjacent. So in this case, the angle is this one on the bottom left. Therefore, the adjacent side is the one next to the angle. Literally, adjacent means next to. Right? The opposite, just like we always think in terms of a direction, opposite is going to be across from it. So with this triangle, this is the opposite side because we're talking about this angle. Right? The adjacent side is next to it. If we move this angle to the top and we were talking about this angle, then the opposite and adjacent would flip and switch terms. Hypotenuse would always stay the hypotenuse because it's always across from the right angle. So again, A and O, the adjacent and the opposite, always depend on the angle that we're using to be able to answer. Now, we can find missing sides of a triangle a couple different ways. The easiest one is Pythagorean theorem. A squared plus b squared equals c squared. We're going to use this if we know two sides and just need to find the third. C is the hypotenuse, always, 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 because it's the biggest. All right, and then A and B are the other two sides. Mathematically, it doesn't matter which one's A and it doesn't matter which one's B. If you're doing math, A doesn't have to be opposite and B doesn't have to be adjacent because A plus B is the same as B plus A. Their order does not matter. The hypotenuse does, though. So here's an example. I ask you to work this one out on your notes. So if we had a side that was where the C was 10 and the B side was 4, we should be able to figure out the A side. Now, again, you see this, you've got two sides. And then we say, okay, Pythagorean theorem, A squared plus B squared equals C squared. Plug your numbers in, substitute a 4 in for B, substitute a 10 in for C. And again, pause this if you need to write and keep up. And then if I square the 4, I get 16. If I square the 10, I get 100. So a squared plus 16 equals 100. And I'm trying to get a by itself ultimately here. And we kind of do reverse orders of operations when we're trying to get a variable by itself. So I need to get rid of this plus 16. So I'm going to subtract 16. That's going to take 16 off of the left and make it go away. It's going to take 16 off the right and make it 84. And now this is kind of like one of the formulas we used in the first unit. Since I'm trying to get a squared, I can't just leave it at 84. I need to take the square root of 84. So because I want to get the answer to be a. And so in this case, a would be approximately 9.2. Yeah. So if you need to pause and kind of go through that again, please do so. But again, this is just some things you've done in math before, and we'll continue doing them now. All right. So what if we know one side and one angle, not two sides? All right. So this is when we're going to use some trig functions, sine, cosine, and tangent. And again, you should have done these before. These are on your reference sheet. You don't have to memorize them. They're actually on side 2 of the reference sheet. So if they're taped to your table, you can't see them right now. But you can get your own copy and you should be able to see them. So we're going to use this when we know a side and an angle of a right triangle. And it has to be one angle that's not the 90-degree angle. We always know what the 90-degree angle is. And then this symbol, this is a Greek symbol theta, T-H-E-T-A, and it represents just the angle. So if we say the sine of theta, we're saying the sine of the angle. So if we go back and look at our triangle again, in this case, if theta is down here on the bottom left, then this side is the adjacent, the other side is the opposite, and the other one's the hypotenuse. So these are the formulas and how they are put together. Again, we don't have to memorize them because we've got access to them all the time. We need to rearrange them, which I want to ask you to do in just a second on your note sheet by making a triangle, because this fits into the same thing. Now, when we have the sine of the angle, you just want to consider that sine theta to be like an X. So when we're using a triangle, that whole sine theta thing would go into one of the 3 boxes that we have there. So this shows how to rearrange them. And then we've got some other things we'll do here later with this negative tangent, but we're not going to do that today. All right. So when we solve this, if we got a triangle, and again, we know an angle and we know a side, and we're trying to find the other side. We're going to work through these as examples, and I'm going to ask you to do some of your own. Again, I'm probably going to move through these quickly, pause and stop if you need to. So X is the hypotenuse because it's across from the right angle. 38 is my theta because that's the angle. And 17 is opposite because it's across from the 38. Remember, that's always defined by the angle that we've got there. So then I had to think, which formula do I need to use? Well, I've got a hypotenuse and an opposite. If I've got the H and the O, then I need to use the sine formula because the sine formula is the one that has the H and the O. So I've got sine of theta is opposite over hypotenuse. Now, again, I'm trying to solve for the hypotenuse. So if you go back and use your triangle and show how to rearrange it, you should rearrange it so the hypotenuse is the opposite over the sine of theta. Once we put that in, again, your opposite was 17, your theta is 38, and you want to put it in like this. And if you put it in your Desmos calculator, it should look like this, and you should get that answer. So pause now if you need to, so you can kind of get yourself caught up and work through the problem. Again, rewind if you need to. One little note on using your Desmos calculator, noticed this a lot last year, do not use the graphing calculator to do these. You need to be using the scientific calculator because you're going to get things wrong. The scientific calculator defaults to using degrees, which is what's going to give us the right answer. The graphing calculator doesn't. It uses radians, which is different. And you'll notice on the previous question, if I put the exact same thing in, I get a different answer. And that one's going to be wrong because there's only one right answer. So to do these sines, cosines, and tangents, we need the calculator to be in degree. The scientific calculator defaults to that. So we're going to work a few more of these just as examples. Again, let's identify each part that we have. X is our adjacent side because it's next to the 52 degrees. 52 degrees is our theta. And then 15 is the hypotenuse because it's across from the right angle. Once we have that, we should be able to say which formula do we use because I've got the adjacent and the hypotenuse. If I've got the adjacent and the hypotenuse, then I need to be using the cosine formula. So I'm going to write that out. I'm trying to solve for the adjacent side, so I'm going to need to rearrange this. This is again where using the triangle comes in helpful if you need to. So if we rearrange it, we should get adjacent equals the hypotenuse times the cosine of theta. Once we get that, we just plug it into our calculator where the hypotenuse is 15. Actually, this should be times. I messed up with my little typo right there. So again, this should be 15 times the cosine of 52. Make it look like this in your calculator. Don't put a division there. I always seem to have one thing messed up in my videos. And we're going to get an answer of 9.2. The other thing I would check is, does this number make sense? Well, remember, 15 should be the longest side of my triangle because it's a hypotenuse. X should be less than that, and it is. So at least I know that I'm kind of in the ballpark with that. Pause so you can have a chance to copy this and write it down if you need to. All right, we're gonna do a few more. Again, identify each part. In this case, X is the hypotenuse because it's across from the 90-degree angle. Theta is 57 degrees, and 20 is the opposite because it's across from the 57-degree. Once I've identified the H and the O, that tells me which formula I can use. The H and the O need to have the sign again. There's the sign formula that we can look up because we don't have to memorize it. We're trying to find the hypotenuse in this case, so I do need to rearrange it. So if you use your triangle, we can practice rearranging it. Once you get it successfully rearranged, it should be the hypotenuse is the opposite divided by the sine of theta. And we plug our numbers in. Again, we should put 20 divided by the sine of 57. And I'm going to get this number in my calculator. Again, if you didn't, then you're probably using the graphing calculator. Does this number make sense? 23.84, that's the hypotenuse. It is the longest side, so it should be slightly longer than the other side that we have over here. Pause for a moment if you need to, so that you should get things done. All right. I think this may be the last one. Again, if we want to try to find the length of this side over here, X is our adjacent because it's next to the angle. You got to always start with the angle. 47 is our theta, and 13 is the hypotenuse because it's going to be across from the right angle. Which formula? I actually think we got one more example after this. Hypotenuse and adjacent, again, use cosine. So we're going to go back to our basic cosine formula. Once we need to rearrange it because we're not solving for cosine of theta, we're solving for the adjacent. So I need to use my triangle to rearrange it, and my formula gets changed around. Plug our numbers in. Got it right this time. So cosine of 47 times 13, stick it in the calculator, and we'll get the length, 8.8, which kind of makes sense. It is shorter than 13, which is what it should be. Okay, one last one, and I believe this one uses tangent. So again, we're going to ID each part. X is my opposite because it's across from my angle. The angle is 50, and 22 is adjacent because it's next to the 50-degree angle. So if we got O and A, we're going to use the tangent formula because that uses opposite and adjacent. So we're going to look at our tangent formula. We're solving for opposite, so I need to rearrange the formula. When we rearrange it, adjacent is going to move to the other side. And then at this point, we just stick it into our calculator. Again, tangent of 47. This is, again, how you need it needs to go in the calculator. I made another error there. That's supposed to be tangent. So opposite equals tangent of theta times adjacent. So again, this should be tangent, just like I've got in the calculator right here. And we should get 26.218. That's what happens when I copy and paste things sometimes. All right, so here's your to-do with this. You've got a few practice problems to finish working on to see if you know how to do this. There should be some answers for this to you. When you finish this, I need you to take a photo of it, either using your phone or the computer, and I need you to upload those images to check off that you have done this. Instead of me coming around trying to check it every day, this makes it a little bit easier. So when you're done with it, you can take a picture. And if you need help with that, please ask. Make sure your name is very visible so that I don't give you credit for taking someone else's work or if it's scratched out or whatever it will. So make sure you're doing your own stuff. Make sure you're doing your own practice. Once you finish that, I'll have signed in pair assessment some trigonometry practice of how to, just make sure that you know how to do these things. And this will take care of us for the next couple of days.